Hello guys. So today is our 7th project from our web programming and database management systems. And today our project requirement is making an EER diagram for an e-commerce application which is based on electronic items. So let's straight go to the concept of our project today. So this is the concept of today's project. Here you can see I have a user and I choose to select them to be a buyer or a seller. A seller can have products and sell history from his orders. So in the product section, I have the products in the site like this and have brands which are distributed by a distributor for the site. And I have offers, anonymous FAQs for these products. So when a buyer wants to purchase, buyer will go through the seller's products and give the order. From the order, the seller will have a sale history and the orders will get the offers directly from the offer table, and through orders, buyers can give ratings to that particular product and the seller. After the orders, the payment section comes up, and from that payment section, an invoice will be issued for the buyer, and buyer can see the shipment details of that order. A user can have a cart and a wish list about the desired items of the user. And all of these site tables and sections will be managed by an admin in the site which have access to all the database and can see all the records of users, buyers and sellers, and all the orders, ratings, etc. So now let's go to the EER diagram. So in this EER diagram, I have an admin table here which contains names, emails, passwords and mobile number of those admins. And here's our user registration table. For this, the user needs to give the first name, last name, mobile, email, password, and address, city, and the account type. So for this address, I have normalized this table giving a relationship like this. So as you can see here, for this address, I have an address table connected with non-identifying one-to-many relationship. It's like this. One address can have many users, as this application can have many users from the same home, from the same office, from the same apartment, likewise. So the address can be same to many users. And in this address table, I have some foreign keys stated, which is city ID, state ID, and country ID. I have connected all this to this address table with non-identifying one-to-many relationships. So one country can have many addresses and one state can have many addresses. One city can have many addresses. So it's like this. And I have made a city table to normalize this again. And in the city table, apart from the city, I have a state ID which I got from the state table, connecting it with a foreign key. And I have used the same relationship as before, because one state can have many cities. In this state table, you can see a foreign key is given like this, country ID. I have used identifying one-to-many relationship for this foreign key relationship. It's like this. One country can have many states, but the same state can't be repeated to other countries, as that state is unique to that country only. So this identifying relationship is used to achieve this uniqueness. And now let's move on to the account type. I have used non-identifying one-to-many relationship to get the account type for the user. This account type is like this. One is buyer, one is seller, and other is both. Like that user can be a buyer and a seller simultaneously. So now let's directly move on to the product section. So in this product section, you can see I have a product table which have ID, a brand ID, name, a product image which is the path of the product, and category ID, quantity, price, specs as in a description for the product, and product type ID. Brand ID, category ID, product type ID are all foreign keys which I got from other tables. Let's start with the brand ID. So I have connected this brand table with this product table. And in this brand table, I have the brand, a logo, which is the part of the brand logo in our project, and a description of the brand. When a brand is marketing, that brand needs to have a distributor company to give those items to the society. So we have a distributor here which contains the company name, company logo part in our project, and a description about the company. I have used many-to-many relationship to connect this distributor and brand table, and this connection is an identifying relationship, as that one distributor can have many brands but doesn't need to repeat the same brand again and again. That distributor can update the purchase limit. So when making a many-to-many relationship, I get this distributor has brand table which contains the distributor ID and the brand ID. And I have connected this distributor with this product table with another many-to-many identifying relationship, as that particular product can have many distributors and distributors can have many products as well, but doesn't need to repeat the same product in the records, and they can choose to update the distribution limit or the product limit of those items, and no need to add another row for these tables. And now let's go for this product type. So in this product type, this type is like this. A product can be a second-hand one or a brand new one. So the product type is like that. And I have this category table here, which has the category of my electronic devices like phones, laptops, TVs, mobile accessories, gaming accessories, likewise. So this category can be changed for each product, and one category can have many products as well. So I have given a non-identifying one-to-many relationship for these two tables. And I have an offer table which have the product ID and the offer price, a starting time and the ending time of the offer. So I connected this product with the offer table with an non-identifying one-to-one relationship, as one product needs only one offer. So one offer is needed for one product only. And now let's go and see our sellers and buyers. So we have a buyer table like this and a seller table like this. In this buyer table, I have name, email, shipping address, and contact of the buyer. We can fetch those details from the web application user table to this buyer table with the help of the web application queries. And for the seller, same coding style and query style can be applied. And the seller has name, email, and contact number. Now let's check how these sellers and products are connected with each other. I have used a many-to-many identify relationship to connect the product table and the seller table like this. And this product has seller table is made with the relationship. In the table, we have the product ID and seller ID. With this identify relationship, I am obtaining the scenario where a seller doesn't need to repeat the same product. So this identifying relationship is like this. And I have a stock quantity in this product has seller table and the seller price of that particular product. As sellers are needed to have profit from the original price, the site gives items to the seller. And here, let's go to the buyer having an order. So in this order, I have used identify one-to-many relationship here, as one buyer can have many orders, but orders can't be repeated with the buyer ID. Like the buyer can't give the same order twice with the same order ID. And we can have queries to change these order ID numbers to get this done in our web applications. So for this buyer and order relationship, in the order table, we have buyer ID here. And I have connected the product has seller table with the order table to obtain the seller ID and the product ID of that particular seller and the shop. So this order table have those foreign keys like this, which can't be repetitive, and we have 3 more foreign keys, which is brand ID, category ID, and offers ID. I have called those foreign keys with the help of one-to-many non-identified relationships. And we have time for this order, a quantity, and a discount, a total price section for this order. From the order, a sell history will be generated for the seller and can be accessed to the seller from the seller page in a web application. And for the seller history, we have this order ID to identify which order gave this seller history, and the buyer ID to see who orders this product, and the seller ID and the product ID of the seller. So which means this time we can identify who wanted this product, who sold that product to the buyer. Likewise, continue with this order and sell history. I have used an identifying relationship to connect these tables, which means one sell history can have one order and one order can have only one sell history. From the order table, we are directly going to the payments table and the shipping table. From the shipping table, I have this ship method called from a relationship as a foreign key to this shipping table. The ship method consists of free delivery, paid delivery, and the delivery type like China Post, airlines, likewise. So in the shipping table, we have the ship method and the order ID, the buyer ID, and the product ID, and the arriving date here. And all of this ship method, shipping, and orders tables are connected with one-to-many non-identifying relationships. Now for this payments table. In this payment table, you can see I have connected it with the order table with an identifying one-to-one relationship, as one order can have one particular payment type, and that order ID doesn't need to repeat the same payment in the next time. So the restrictions are placed like that. And let's say the payments table here. In this, I have order ID and the buyer ID and the product ID from the seller and the seller ID from the seller as well. And I have got more foreign keys like this: payment type ID, bank ID, branch ID. After that, we have the card number and the timestamp for this payment. So I have made these tables for those foreign keys, and you can see I have this payment type table here, which consists of the methods there are to pay the amount. So for these methods, we have cash, card payment, PayPal, likewise. And we have another table called bank here, which connects with the bank branch with an one-to-many non-identified relationship. And I have connected bank branch with the payments table as well. So for these connections, I have used non-identified one-to-many relationships, as one bank can have many payments, one payment type can have many payments, and one bank branch can have many payments, and a bank can have many bank branches likewise. So straight from this payments table, the invoice table will generate the required fields here, and the invoice and payments table are connected with one-to-one identifying relationship, as one always needs only one payment and one payment only need one invoice. So this invoice table consists of the payment ID, the order ID, the buyer ID, and the product ID and the seller ID. And we can give queries to insert details for other required columns. Jumping straight again to the order, we have a ratings table to rate that particular product from that respective seller. And I have used non-identified one-to-many relationship here, as one order can have many ratings, and this ratings table consists of the order ID, the buyer ID, the product and the seller ID, and the rate. And for those buyer IDs, we can choose to give the buyer name with the rating or not in our web application with the help of those queries we use. Another table I have is the FAQ table for asking questions on those products in our web application. And this field is anonymous, which means any user can ask any question about the product, and the user details who posted those FAQs won't be released. So in our FAQ table, we have ID, the product ID, the question, and the answer. In our product ID, I have connected this FAQ table with an one-to-many non-identifying relationship, as one product can have many questions on it. So likewise, we have finished the product side and the orders. Now let's move on to the cart and wish list of any user. So in the cart, I have used a one-to-one identifying relationship to make the relationship between the user and the cart, as one user can only have one particular cart. So in this, I have connected this cart with the product table using and identifying many-to-many relationship. As you can see here, the cart has product table consists the cart ID and the cart user ID and the product ID from our products table, and the quantity and price is like this. You can see here I have chosen this identifying many-to-many relationship to give the uniqueness of the product in the cart, as one cart doesn't need to repeat the same product. And let's go to the wish list. Again, I have used identifying one-to-one relationship to connect the user and the wish list. And I have used identifying man-to-man relationship to connect this wish list and the product table again. And for this wish list has product table, I have the wish list ID, wish list user ID, and the particular product ID. And using this identifying man-to-man relationship, I was able to restrict users from having the same product over and over again in our application, and chose to give uniqueness for those cart and wish list. So that's all for my ER diagram explanation, and you can see this whole ER diagram like this. We are using this database to a web application. So for those tables, we can give queries to fetch results from those joined tables that have relationships. And that's all for our concept on this project today. Thank you for watching and have a nice day.